Recording now. Yo, we look so much better. Look how cute you look.
Thanks.
Hey guys.
Hola, mi amigas and amigos. So, Chris, what are we talking about today?
Today, we're talking about the elephant in the room. It's like, no. Before we can go there, we gotta have a foundation, darling. We're gonna be talking about what is a virus.
What's a virus?
What is it?
What's a virus?
You know, what's this thing that got tout le monde on lockdown?
Everybody on lockdown.
Everybody on quarantine, you know? Our textbook definition for a virus is a non-cellular particle that must infect a whole cell, and that is where it reproduces. So because of this, the fact that a virus is dependent on our host, there's so much debate in the scientific community. You know, the scientists, they had a frenzy about it. They can't agree, all right? Some think that it's a live organism. Some say, well, in order for one of the criteria for being alive, you got to be able to reproduce on your own. Some saying because of that, since they need us, then they're not alive. Some say, well, it could reproduce in us, so it is alive. So, you know, it's tomato, all right? Tomato at this point. A virus typically hijacks a cell's machinery and it directs that cell to produce viral particles. All right, viral diseases, we don't like them too much, all right?
You can't have corona without the virus. Coronavirus.
We hate them, viral diseases. We can't stand them. But viral diseases have led to the development of some of our earliest vaccines. So I'll give them that. Viruses are ubiquitous in all environments, meaning that different viruses infect every group of organisms, y'all. Like viruses is stepping on everyone's necks. Viroids are viruses that infect plants. Prions are viral protein particles that infect animals like cattle, for example. And bacteriophages are viruses that infect bacteria. So they everywhere. Nobody likes them.
No.
They're always searching for a host. These things are so tiny. She tiny, but she mighty, y'all. They're smaller than bacteria. Could you imagine something, bacteria, we already can't see them.
Right. So imagine something smaller than what you can't see.
Smaller than that can also infect bacteria.
You can't imagine that. You can't imagine that.
These super tiny things are either naked or enveloped.
Right.
Naked meaning that they don't have an outer capsid. Envelope, obviously, they have the outer capsid. There are many ways to classify viruses. We're only going to touch on two for the sake of the video. We'd be here all day.
Right.
We're going to talk about classifying viruses by their genomes, meaning are they an RNA virus or a DNA virus? They can't be both. She got to pick one. All right? She can't have it her way. They say Burger King.
Yeah, that's not.
Another way that that we're going to be touching on how viruses are classified is by their host range, meaning can they only infect this specific species, this specific organism, or can they infect that organism and humans, for example?
So now we're going to talk about the virus life cycle, okay? So a virus' whole purpose is to reproduce itself. It can't do that on its own.
Yeah.
So it needs a host cell.
Yeah.
Right? So viruses are very specific when it comes to their host cell because they want to target very specific receptors outside of that host cell.
Yeah. It's like a lock and key. If you don't have the key, you can't get in.
If you want to fit,
you gotta submit.
So for the virus to even be able to attempt to do that, it has to be compatible to the receptors. Once inside the nucleus, the DNA of that virus or the RNA of that virus transcribes to RNA. Now our host cell, not knowing that an invader comes in and the entire machinery process translates that viral RNA or DNA and replicates the virus within the cells. So now the virus comes in, it tricks the host receptors, it inserts the DNA into the nucleus or RNA, it gets transcribed to RNA. The RNA then gets assembled to assembled proteins. And now its host cell is voluntarily, without knowing, making viral genetic material.
Yeah.
Evil! So, as Chris stated, They are either envelope or naked. Envelope virus can use the receptor tomfoolery that we just previously spoke about. And these guys sometimes just diffuse their envelope into the membrane of the host cell.
Yeah.
So, Chris, can I use your hands?
Sure, you can use my hands. Here are my hands.
So, these are the exterior of the cell wall, and the receptors are on there. And here I am, an enveloped virus. This is the envelope, it's the capsid, this is the virus. Here I am, I go in here, and then I diffuse, and this little guy right here, the virus can't diffuse, and this little guy right here, the virus is just in there. And you see how I did that? Just, it's an extra protectant, it just makes it super easy to get in there.
Yep.
So that's the
That's
envelope.
how it goes.
That's exactly how it goes. Yep. With a British accent. So there's two different ways that the virus conquers. First is the lytic cycle. So this is more aggressive, if you will. Okay? The virus, once infiltrated into the cell, is super excited and impatient, and it just wants to go crazy. It wants to go nuts.
Yeah, bonkers.
This type of life cycle is called a lytic cycle. It's going to come in. It's going to sync up the proteins that help with replication. It's going to have them replicate that viral genetic material until there's so many of them that it gets so crowded in the cell and the cell bursts.
Yeah. It just busts wide open.
Lysis. It busts wide open. And now all these little happy viral cells and genetic material go and find other host cells
to infect.
And it does the same thing over and over again. So that's the first life cycle. The second type of life cycle that a virus can have is a dormant one, lysogenic cycle.
Yeah.
This one's a little bit more quiet, less aggressive.
She sneaks.
She's sneaky. She be on her chippy heels. So it inserts itself into the host genome, and every time the host replicates,
it replicates.
It replicates the viral genome.
Silently.
Quietly. Nothing's happening though. They're all just sitting there replicating. It's a whole bunch of them.
Yeah.
Until it gets some sort of environmental cue that the whole cell is weak.
Yeah, it could be stress, maybe you're getting ill.
Right.
You know, something environmental that's letting it know like, oh, she weak now.
She weak, right.
So weak right now, so let's go off. Let's pop off.
So it triggers the virus, and the virus is basically like, hey yo, what time outside start? Like,
what time outside?
This host I'm in is super weak. I think I'm finna pop out. It's not gonna do anything to me. And that's what it does. So now the once dormant virus goes into a lytic phase, like the lytic cycle, where all of the things that it created just kind of burst out of the cell.
All right.
Okay? And it goes infect other cells. So something similar to that would be kind of like the cold sore.
Yeah. So the cold sore, you may have that specific strain of herpes. It's just sitting in you silently, just growing, replicating.
Yes.
Let's say you're under a tense amount of stress. Let's say the weather changes or something like that. The air is more dry. It's like, all right, she about to get sick. Let me pop off. She can't.
They're not gonna know what hit them.
And then you wake up with a cold sore. True story. That's how it happens.
It's active.
So, before we can touch on the obvious elephant in the room that got us on lockdown, before we can touch that, we're going to touch on the emergence of new viral pathogens, all right? How does a seemingly new virus emerge to infect humans? Like, how does that happen, right? That is a valid question. That is the question of the day, the question of the hour, the question of the year. We're only 3 months in. And this is the question, all right? So,
viral domination
at this point. So, I'm going to talk about 3 different ways that this happens, how new viral diseases emerge. One would be the result of human consumption of wildlife. For example, the SARS virus is an example of that. Maybe you guys have heard of mad cow disease. I don't know how common that is to everyone, but it's a virus a prion that infects cow.
That was popular back in the day.
Honey.
They had it.
And when they ate it, not knowing, obviously, they developed Creutzfeldt-Jacobs disease in humans. So that's the first way. The second way I'm going to touch on is a variant of an endemic. Endemic meaning a regularly found mild pathogen, you know? Like, it could be like the common cold, for example. You can't catch the same cold twice.
Right. You don't.
You know what I mean? You don't. once your body has built that immunity, if you get a cold again, it's a new one. So it's like a new variation of that. And also the flu could be a perfect example of that.
Influenza is a perfect example.
Yeah, and how they like change from time to time. The third way new viruses emerge to infect humans are the concept of co-infection. Co-infection of a host with multiple viruses can result in the mixture of genomes. Mixing of these new viruses can cause a change in the receptor recognition that Val was talking about.
Right.
So that can cause them to change their key. Maybe their key can only open one door, but now they key change, they can open 2 doors.
But the virus is willing to take that risk.
Yeah.
Because its main goal is to be present.
Yes.
And to be relevant and to be replicating.
Yeah.
So it's very open. It has no standards. Okay, it's not into specific. It don't got no standards.
She was promiscuous. All right.
That virus is down with anything because there's a chance that it's gonna make it better and make it more susceptible to be received by the receptors of whomever.
And whatever.
Whatever host.
Yeah. So a perfect example of this will be, let's say 2 different strands of an influenza virus infects a host simultaneously, right? So these 2 different strands of influenza can reassort their segments and generate a novel hybrid strain. So they can come together and combine and make something completely new.
Right. It's still influenza. It still has that foundational template.
Yeah.
But honey, boo-boo. They done grabbed so many different things. This is the new improved one.
You know what I'm saying? Influenza viruses can quickly generate a new strand that our immune system cannot recognize. All right? So our immune system is just like,
I'm sorry to that human.
I'm sorry to that human.
I don't know who that virus is.
I have no idea who that man is. That man virus, and then I don't know who that is.
I don't know who he is.
So, influenza, keeping on the same example, they also continuously acquire small little mutations. You know, over time, they're getting these small little mutations, little tiny changes. It's not really doing much. And then all of a sudden, those small mutations add up. Once that happens, that can lead to drug resistance.
Right.
Perfect example of that is you've heard instances where this year's flu vaccine may not be effective as last year's.
Right.
Or good news, this year's flu vaccine is more effective than last year's.
Right.
And stuff like that. Or those small little mutations over time can also increase host range, as I was saying before.
Mm-hmm.
Maybe that virus can only affect birds or swine
right.
at one point. And now mutation happens, they can now infect humans.
These are the new strands that you hear a lot about.
Yeah,
so
like
these
swine flu,
right.
bird
These
flu.
viruses were always there. But now because they were able to gather different mutations, their composition is still has that basic foundation, but it's kind of a new strand that has more range.
Yeah.
So now it affects,
she got range now.
She got range.
She got range.
She was affecting birds, now she got the humans. She was affecting gorillas, now she got the humans. She was affecting cows, now she got the humans.
She was affecting swine, now she got the humans. So that's viruses.
That's viruses. So we hope you grasp the concept. We hope that everything made sense to you. Use Curious Cat to ask us questions. If you have any suggestions.
We hope that you guys learned something. We hope that you stay curious. And remember, health is wealth. Oh my gosh.
Doobie doo boo ba ba doo ba da ba day.
Hey.